All right, so we've talked about vertical asymptotes. Now let's talk about horizontal and slant asymptotes. Those are going to be a little new. Here's what we do. To find horizontal asymptotes of rational functions, you look at the degree of the numerator and denominator. And we've got three cases. If the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote at the y-axis. Sorry, the x-axis. If the degree of the numerator is greater than the degree of the denominator by 1, no horizontal asymptote. Okay? And you have a slant asymptote. We'll talk about what that is in just a minute. Degree of the numerator is equal to the degree of the denominator. There's a horizontal asymptote at the ratio of the leading coefficients. What if it's greater than the degree of the denominator by 2 or more? You have no horizontal asymptote. Okay? So really there's 4 cases, but these are the cases where there is something interesting happening. So let's look at some examples. Case 1, degree of the denominator is greater than the degree of the numerator. So this is x squared, this is x. That means your horizontal asymptote is at y equals 0 at the x-axis, okay, this green line. Okay, so the end behavior, this goes to 0, that goes to 0. As x approaches positive or negative infinity, f of x approaches 0. Okay, so that's the first case. The second case is if we have a slant asymptote. It happens when the degree of the denominator is less than the degree of the numerator by 1. So this is squared, this is to the first power. The difference is 1. You're going to have a slant asymptote, and it looks like this. It's just a line, okay? We'll go through an example of how to find what that line is in just a minute, okay? And the function looks kind of funky like that, okay? Like two kind of like twisted parabolas, kind of. All right, third case is that they have the same degree. All right, so this has degree 2, this has degree 2. Then you look at the ratio of the leading coefficients. So this is 3, this is 1. The horizontal asymptote is going to happen at 3 over 1, or 3. And here we see the horizontal line y equals 3. There is the horizontal asymptote. Okay, so it's the ratio of the leading coefficients. If this was... So in the cases, if the difference in degree is bigger than 1 and the degree in the numerator is greater, you do not have a horizontal or a slant asymptote. All right, so let's look at these 3 functions. And you might want to just pause and think about what kind of horizontal or slant asymptotes they're going to have. Let's look at A. We look at the degree of the leading terms, the degree of the functions. They're both x cubed. They have the same degree. So what does that mean? This is case 3. We have a horizontal asymptote at the ratio of the leading coefficients. So at 6 over 2 or at 3. All right, how about B? Which case is this? X squared, x, degree 2, degree 1. This is greater by 1, so we are going to have a slant asymptote. Here's how you find the slant asymptote. You actually divide the function. Okay, and this is a linear term, so we can use synthetic division, right? So this is supposed to have a minus sign out front. The book made a mistake. This is a minus 2. Okay, so we divide the numerator here, 1, negative 4, 1. Those are the coefficients by x minus 2. That should have a minus. All right, bring it down. Add. Bring this over, negative 2 times negative 6 is 12. We add, we get 13. Okay. Here's what we do. We ignore the remainder. Don't care what it is. Okay, we look at these coefficients. X minus 6 is our slant asymptote. Okay, and let's look at Desmos for just a minute. So here's what the function looks like. I just put in the function x squared minus 4x plus 1 over x plus 2, right? And here's the slant asymptote. There we go, x minus 6. Okay, so the way we find that is by doing synthetic division or just doing regular division. And these coefficients of the first two terms, or all the terms except the remainder, are a slant asymptote. We'll always get a linear, it'll always be linear because the difference in degree is only one. So we'll always have a linear term, and those coefficients are our slant asymptote. Okay? All right, let's look at case 3. The degree of the denominator is bigger than the degree of the numerator. So the asymptote is going to be at the y equals 0 at the x-axis. Why is that the case? Well, when x gets really, really big, this gets bigger than that, right? This ratio goes to 0. So, sure enough, horizontal asymptote at y equals 0. All right, let's find the horizontal and vertical asymptotes of this function. They have it factored for us already. Okay. Well, that's actually not very helpful, but it's factored. We wish that it wasn't factored, right? This is going to be degree 2. This is going to be degree 3. So what does that tell us? The denominator is bigger than the degree of the numerator. So there's going to be the y-intercept, the y asymptote is at the x-axis, y equals 0. Okay, so there's a horizontal asymptote. How about vertical asymptotes or removable discontinuities? Looks like nothing is going to simplify. So our vertical asymptotes are going to happen at 1, -2, and 5. 1, -2, and 5. Yep. And yeah, that's all we needed to find there. Okay, we found the horizontal and the vertical asymptotes of this function. Now, they're going to ask us same exact function, find the intercepts, the x and y intercepts. Okay, well, the y-intercept happens when x equals 0, right? So we can just plug in 0, evaluate this function at 0, just like we would with a quadratic, with any other kind of function. And we get -0.6. Where the x-intercept is going to happen? The x-intercepts are going to happen where the whole function is 0, and that's going to happen where the numerator is 0. Okay, the x-intercepts happen where the numerator is 0. Okay, so at 2 and -3. So let's look at that graph again. Yep, at 2 and at -3, we have x-intercepts. And at -0.6, we have a y-intercept. Okay, so we're going to put this all together soon, and you are going to be creating these graphs. Okay, but for now, in this section, we just talked about finding horizontal and slant asymptotes and also the intercepts.